Okay, hi. Today we are going to talk about what do we do when there is no scale bar on an image that we want to use for measurement of cell size or cell body diameter, anything like that, like the one that we have right here. So this is something that I have talked about in other videos about how we calibrate using an image that we have taken. But then I've gotten a lot of questions from students about how is it that we are able to calibrate using an image from the microscope itself, from the scale bar. So we are going to talk a little bit about that today. So in order to have accurate measurements of these cells, what we need to have are two things. One, we need to have a slide which has a little ruler on it, and that slide is called a stage micrometer. You can find them online very easily, even on Amazon or eBay, but they are sold at all science supply stores in general. It's just a regular slide that has an embedded ruler with a known distance on top of it. And we have talked about how we use that to calibrate our actual physical microscopes before. Now, in this case, we don't have an actual physical microscope, and each microscope that we may use is going to have different calibration of its ocular micrometer. So what we need to do in this case is that we need to make sure that we have images of the stage micrometer, of that slide ruler, at the same magnification as your image that you are wanting to analyze, as well as using the same microscope. So let's say that I had a microscope that I was using to take the image of my slide with these cells using the 100x magnification, so using the 10x objective lens. Then I also need to take an image of my stage micrometer using the 10x objective lens on the same exact microscope. For best results, you don't want to get those images from different microscopes, even when they're of the same company and everything, because there may be slight variations, or there may be slight issues with the calibration of one microscope versus the other. So you want to take the image of your stage micrometer using the exact same microscope that you're using to get your images for analysis. And the stage micrometer images should be at the same, using the same objective lens that your images are going to be. Now, one of the things that you can do is that, let's say that you have some data points that you need to collect using various magnifications, or maybe you're not sure which one you're going to be using at any given time. Then you can make a library for yourself where you have the stage micrometer image taken using the microscope that you have for every single objective lens. So here I can show you that there is my image using, I have two particular microscopes that the students use in my teaching lab. So for each one of the microscope, and I have it labeled on top that it's the front microscope or the side microscope, I took the images using the stage micrometer with the stage micrometer using every single objective lens on that microscope. So here I have it at the 40x magnification using the 4x objective lens. So this is your bird's eye view, right? The scanning objective lens. And from with the same slide on there, same microscope, then I took the image at 10x objective lens. So this is my image under the microscope at that time. Then I have one 40x objective lens, and then I have the same slide image using the 100x objective lens. So you can see how each time you're seeing a more and more zoomed in view of the stage micrometer, and so it is showing you how the magnification changes as well as you are going up the magnification. So how it changes the look of that image. So let me show you how that would look under your image J. Now, in order to use these calibrations in image J, you do need to know the stage micrometer's own length, and you need to know what each one of those stage units are worth in distance, in micrometer, in actual physical distance. So here I'm going to go ahead and I'm going to show you how we would have worked with this. So I'm going to go ahead and first of all open this with my 4x objective lens. Here is my image. Now at the 4x objective lens you can see the entire micrometer, right, the entire ruler, and you can see a lot of other extra field as well. So in this case, it's really hard to take the measurement of every single unit, right? Each individual unit. So in this case, what I would have done would have been to, get my image, and I would have taken my distance, the line tool, and I would have taken the measurement from one of these big lines till the middle of the second unit, the big line, which are identifying 10 units at that time. You want to make sure that your line is straight, right, that it's not tilted on one side or the other. Mine is a little bit tilted there, so I'm trying to correct for that. And then you would go to, you can do one of two things. You can just measure first, or you can go to set scale. And now you can see that it says the distance in pixels. It says it's 109 pixels. Well, I know that between these two, the entire length of my micrometer, stage micrometer, was 1,000 micrometers. And so each one of these big units, there are 10 big units, 10 large units, is going to be 100 micrometers. So I can say that this one is supposed to be 100 micrometers, known distance, right? And I can write that, and then I can click OK and get that information. Now, I'm not actually sure if I had a scale on that already, so I'm going to just do it just another time. Set scale there, so the known distance is 100, and these are in micrometers. And so it tells you that you have about 1 pixel per micrometer in this case. So that's going to be my calibration for the 4x objective lens. If I were to measure a cell or an object using the scanning objective lens, that's the calibration that I would want to use. Now you could make a chart for yourself, and you could save these calibrations so that the next time around you don't need to make these measurements again. You could just take it directly, and you can open up your image. You could go to set scale. You could set the scale to whatever calibration you corresponds to the image magnification that you're using, and just start measuring. In this case, that's not important, so we're not going to worry about that right away because we're not actually measuring anything right now. Okay, so let's cancel this, and I'm going to go ahead and open the next magnification, just so I show you how that's going to change the calibration in here. So I'm going to open now the 10x objective lens image. So again, I want to make sure that I'm looking at it at the same, so it's at 49.5. I want to open it at the same thing. And I want to make sure these numbers are the same, 2592 times 1944. I'm going to keep those consistent. Now, let's do the same idea. Obviously, now I only see part of the the stage micrometer. I don't see the entire space like before. And now you can see the individual stage units. But even now, they're pretty close to each other. So it may be hard for us to, again, measure those out properly. So what I'm going to do is, again, I'm going to take from the middle of the first line to the middle of the second big unit. So these are 10 stage units, right? 1, 2, 3, 4, 5, and then 5 more. And so it's 10 stage units together. So again, it's going to be equivalent of 100 micrometer total distance. I feel like this is a little bit overdrawn. There you go. I'm going to go to set scale. Let's see what it tells us now. This time, the distance is 262.8 pixels. Again, the distance in reality is still the same. It's 100 micrometer. That's what we were looking for. So this time, the calibration at the 10x objective lens using that front microscope is 2.6 pixels per micrometer. So I would again make a note of it, write it down somewhere, or you could, save it for yourself in the computer so you know what it is that you would be looking at. So for our 4x objective lens, it was 1.9 pixels per micrometer. And for our 10x objective lens, it is 2.6 pixels per micrometer. And those would be the calibrations we would want to use. And I'll show you how we would use them. Now, let's do one more. So you can see one more, and then I will show you how it affects our measurements. So let's say open. And now I'm opening the next one up, which is our 40x objective lens. And I'm going to make it the same general size. And now you can actually see individual units, right? But just for the sake of consistency, let's just go ahead and look at measurement of 10 units again first. So these are 10 stage units, making sure my line is straight. I set scale, and now it tells me it's 1027 pixels in my 100 micrometers, and that means that my calibration at the 40x objective lens is going to be 10.27 in this case pixels per micrometer. Okay, great. Now let's double check that and see if we would have gotten the same number if I had just done a single unit, which is what I have shown to you before. So you get the middle of the first, go to the middle of the second. So this is a single stage unit now, which means since the entire length of my stage micrometer was 1,000 micrometer, each individual stage unit, because there are 100 stage units, would be 10 micrometer. And so now I can say 109, and it is automatically correctly figuring it out based on our last measurement. But it should be 10 micrometer, and now you can see that the scale came up pretty much the same, 10.7 versus 10.9. So it was within 10% error rate. And so that's the calibration using the using our 40x magnification, our 40x objective lens, or 400x magnification. Okay, so we're going to go ahead and close all of these now because we already have calibrated our image J to the front microscope. We know what those are. We are going to go ahead and copy this number down, however, because we will need that, the 2592 times 1944, which is the resolution at the end of the day that we have in here. So I'm gonna just say no, don't save anything. And let's go ahead and now open one of the actual cell images. So I'm going to go ahead and open an image that was taken using the 10x objective lens. Here is our image, and we have some cells in here that we want to measure. Oops, I didn't open them in the right place. Open, and let's go to this one. There we go. So we have some cells in here that we can measure. And you can see this one is actually at the right, the same, you know, the size resolution is the same. One second. So here we go. Now I want to go ahead and I would like to measure a cell in here to show you what it would look like. So first of all, I am going to magnify it just a little bit. Why aren't you letting me? Okay. Right here. So first of all, we need to set scale, right? Because we are taking images at a particular magnification. And this was the 10x. And we know that 2.6 pixels were equal to 1 micrometer. So we are going to set our scale, right? And I'm going to click global for now, and I'm going to say OK. Now, let's say that I would like to measure one of these cells' body diameter. So I go ahead and draw the line from the edge of the cell cytoplasm on one end to the other. And I go to Analyze and I say Measure. And this gives me the measurement right here in its micrometer. So this is telling me how big this particular cell is. Again, I can make sure that the scale is set correctly. Oh, sorry, I did not set it correctly, so never mind. That was in pixels, so we want to set 2.6 and 1. It looked like it was not correct. Okay, now it is going to give the correct measurement. No. So let's analyze and measure. Now that is, so we know that it's 32.4 for that particular cell. Let's do a couple more cells just to kind of get an idea of the average cell lengths or body diameter. So let's do another one, measure that one. It gives me 37.6 again. So in 30s, let's do one of the thin ones for comparison. And measure this one. And this one is much smaller, obviously, at 12.8. And let's do a last one right here. And analyze and measure this one. And that gives me 31.2. Now, I can show you how that number will change if we were to look at cells in a different magnification. Now, ideally, if we have calibrated correctly and we are looking at the same exact cell under two different magnifications, that cell should be the same length, right? Plus or minus 10%. So hopefully, when we look at these, we still see that effect happen because if we have calibrated correctly. So I'm going to open now the image that I have using the 40x objective lens. Now, obviously, these aren't the same cells. These are different because that's not the same image, but they are dexamethasone, and this is also dexamethasone treated culture. They're the same exact cell line. So you should be getting similar numbers again. So I'm going to go ahead, and the first thing I need to do is change the scale to match the new magnification. So this image is taken using the 40x objective lens. So this one is going to be 10.27 pixels per micrometer. And I will click OK. And let's go ahead and check this one out. So let's start with this particular cell that's right there. I take the edge of the cytoplasm from one side to the other, and I measure. And lo and behold, you get a very similar number to before. Let's do another cell right here just to see the comparisons. This one, and measure that. And you see that they got, again, very similar numbers to before. So even though the calibration was different, it took into account the magnification, and now you were able to get the same cell body measurements, the accurate measurements for both of these images. So the most important part in here is that, one, your stage micrometer images should be taken using the exact same microscope that you're using to collect your images for analysis. And secondly, make sure that you are you're changing that calibration in image A by going to set scale and selecting the correct numbers before you make your observations, before you calculate your measurements. So the scale should be set corresponding to the magnification of your analysis image as you calculated it using your stage micrometer. Hope that helps. And that's it. Take care.